All right, so for today, we read in the book about dictionaries, right? Remind me, what is a dictionary? What, go ahead. Okay. When will we use a dictionary? Like, what's an example of using a dictionary? Okay. So we have, for example, here, we last class with the very end, we decided, okay, we're going to create this idea of a player. And instead of saying player at bucket 0 holds some number, player at bucket 1 holds some number, player at bucket 2 holds some number, we can kind of give color commentary to those individual elements by giving them a key rather than an index number, right? So we can say a player at position hit points, that's the key, has this value, so on and so forth. Okay. Now, the third part of what you read, I think, had you iterating through lists, right? Or through dictionaries. Now, um, there's two pieces to dictionaries. Well, if we go back to our notes here, we talked about a dictionary. We said this is a, we're going to say collection of name value pairs here. It's a collection of name value pairs. If you want to update this based on what you read, instead of name, you can say key value pairs. That makes you feel better. Same thing, but okay, so the names of the keys, the values of the values associated with those keys. All right. So if we write a loop here, so I have a dictionary that has 3 different keys here, right? Hit points, attack power, and defense. So if I say for K in player 1, and then I print out K, notice it gives me my 3 keys. Okay, and that has nothing to do with me choosing a variable name called K here. I could have called this guy Elephant if I wanted to. So there's my 3 keys. Okay. Now, if I wanted to print out player 1 at position, whatever that key is, that will give me the values that live there. Make sense? So there's the values associated with those keys. Now we can also use a syntax for the for loop that allows us to access the keys and the values. So I'll go ahead. So for K comma V, I'll say K is for key, V is for value. I'll print out K, which is going to be a string concatenated with, well, let's put a space in there. Then we'll concatenate that with the string version of whatever V is. Okay, so this should give me, here, I'll even put a little dash. It'll give me a key followed by a dash followed by the value. So we can see what those guys look like. Why did we have to turn this guy into a string for this line to work? Yeah, concatenation requires both sides to be string type. Okay, and we know that we've stored a whole bunch of numbers in there. So we know values are coming out as numeric type. In our case here, because that's what we put in there. Row. That's the syntax for it, isn't it? Oh. I think I have to say this. Dot items. So dot items does what's called an iterator, and I'll tell you about that here in a second. But here's my key, and here's my value. So we can access both of those individual pieces directly through the for loop if we want. But generally speaking, this probably wouldn't be something we would necessarily need. We'd probably loop through, get all the keys, and then work with that. The book introduces some of our dictionary methods. Let's just look at those real quick and see if any of them seem like they're going to be handy to us, or let's say overly handy. So here's dictionary methods. So we can clear all the elements in a dictionary. So that'll give us an empty dictionary. We can get something at a specific key. So right now, I showed you, let's just kind of look at a couple of these. So I'll say for K in player 1, so this is going to be my, K will be each key each time through. We can print out player 1 at bucket K, or we can print out player 1.get K. Those two guys should give us the same output. So each one should be doubled up, 25, 25, 4, 4, 9, 9. Okay, so I can reference individual buckets of a dictionary using our list format, list syntax that we've used, where I said I want this collection at bucket this. So we've used that same syntax for accessing buckets of a string, accessing buckets of a list, and now we can use buckets of a dictionary. Okay, so we're really saying this is our generic syntax for accessing individual buckets of any collection type. Now, dictionaries specifically have a function called get that takes in a key and it returns the value at that position in the key. So that is kind of, let's call this syntactic sugar for this guy. It allows you to look at dictionaries as being something special rather than just another collection type, when they really are just another collection type. One benefit, though, let me show you something here. Here, let me just take this code out. I'm going to print player 1 at position hit points. And then I'll print out player 1 at position elephant. Now we know that we do not have a bucket elephant. We never put that into the dictionary, right? Okay. So right here, let's see, I give it that syntax first of all. Player 1, bucket elephant. Okay, gives me a key error. There's no key called elephant. Program crashes. Okay? Now, if I were to say player 1, let me steal elephant here. If I would say player 1 dot get elephant, and I run it, I get a none value. So it protects it from crashing. I can optionally pass a second value to get. I could say, if you don't find it, go ahead and boil down to a 0, something like that. So there's my 0. That allows you to say, if this key is present, give me its value. If it's not, just assume it's a 0. Or, I mean, it doesn't have to be numeric. You can say the default value is LOL if you really wanted to. But the get function allows you to specify a default value for a key in the event that key is not found, where you do not have that luxury using the generic list access using the square brackets. So if you know the key exists, the list syntax is fine, but just know that the get function that's associated specifically with dictionaries is not absolutely identical to the list function. It has a little bit kind of an additional ability, for some error checking or program crash ability on top of it. Okay. Similarly, we have a update here. This guy's going to work kind of the same way. I can change the value at a particular bucket. So right now I'm printing out. No, we'll leave hit points in there. Then I'll say player 1 dot, steal this. Player 1 at bucket hit points is equal to, let's just do -15. So I'm updating it directly that way. If I print out, we'll just do the get for elephant here. And then I say player 1 at bucket elephant is equal to LOL. And I'll print out each thing after I make the change. So there's what my hit points used to be. Then I changed it. Here's what elephant used to be using get, I used get in this case, but get prevented it from crashing since that key didn't exist. But then I can directly set it. But I can also say dot update. Check the syntax here real quick. All right, so this guy allows me to have 2 dictionaries. Okay. So let me create a second player up here. Call this guy player 2. Go ahead and print out player 2. So player 2 should look a little bit different than player 1, more than likely. Did I print them both out? Oh no, I took out my print for player 1. So there's my 2 players. We see they got different random values. Okay. Now, if I say player 1 dot update player 2, and then I print both of these guys out, we see they're unique initially, but then I've updated player 1 with the values of player 2, which overwrites all identical keys. That makes sense? But now, let me just kind of hack it a little bit. I'll come in here to player 2 and say player 2 at bucket elephant is equal to LOL. And then I'll go ahead and run this again. Initially, player 1 does not have a key elephant. Player 2 does have a key elephant. After we merge them using update, player 1 has all of the existing keys of player 2 and its equivalent values, but has also gained the additional key of elephant. All right, so it merges them together, overwriting any existing keys that match, even if the types are different, but also will add any keys that are additional, something like that. So if we kind of think about this as our from where we're maybe going with our game or something like that, when you get a piece of equipment, maybe a piece of equipment in a game, you pick it up and maybe it has some extra abilities on it or something like that, we can merge that piece of equipment onto the player without breaking the player, but giving them the extra stuff from that equipment. Something along those lines. Maybe somewhat of a forced example, but you can certainly get two dictionaries to contain all the keys of both into a single dictionary. Pop removes and returns the key value from the dictionary. So this guy, it's important. Let me show it to you this way. So if I say player 1, player 2 like this, and then I say player 2 dot pop elephant, I'll go ahead and print out what that guy returns. So this should print my two different players. I'll go ahead, just for the sake of keeping things clean for right now, I'll just take the elephant guy off there. So I should see two unique players. Then, oh, I do need to have the elephant guy on there because I'm about to pop that. So I'm going to see two unique players. Then I'm going to pop the value of elephant, which should give me LOL. And I'll print out LOL. But then we'll print out those guys again, and we will see that elephant has been permanently removed from that dictionary. So here's my two unique guys here. Then I popped elephant off of player 2, and it gave me that result. Here's the value associated with that key. But now notice that player 1 and player 2, well, player 2 is now missing a key it used to have. Notice the difference here between that and saying player 2 dot get elephant. Player 2 dot get elephant still gives me that LOL, but it did not remove it from this guy. So pop gives you the value of a key as well as deletes that key value pair from the dictionary, where get gives you the value of a key but does not delete it. That make sense? That could be a pretty helpful function every now and then. Let's throw that into the into our notes in terms of tools that could benefit us. I'm going to put it right here. Pop function returns and removes. Let's see, returns the value associated with a key and removes that key value pair from the dictionary permanent. That's not how you spell it. Permanently. Get function returns the value associated with a key. And that's it. It doesn't remove it. Keeping it in our video game direction, we're kind of sort of heading here. Let's say you have a health potion. Well, when you use a health potion, you consume it, right? So maybe you have a dictionary that is your backpack or your inventory or something like that. And when you grab health potion, you'll pop a health potion and it will give you a value associated with it, right? So you'll have the actual health potion that you can then consume, but you've also removed it from your backpack. Something along those lines. One thing to look at here, what if I say pop, I don't know, let's say randomly bang on keys. Okay, so this is a key that does not exist. Okay. Okay, this guy, the pop function does throw an error in the event that you try to pop and remove something that doesn't exist. as opposed to get will allow you to request the value of a will allow you to request a key value. But if you can't find that key, it just comes back with none. I came up empty-handed. Make sense? Instead of crashing. In this case, it crashes. So make sure when you're popping for something that actually exists. How could we ask a question where we want to pop something, but only if we have it? Well, how do we ask questions to begin with? Go ahead. Okay, so always use an if we're asking a question, right? So if, now I only want to pop this if that guy does exist. How do I check to see if he exists based on what we've talked about so far?
So you do like if player 2.get doesn't return a none, then you delete it.
So if this guy is not equal to none, we'll go ahead and pop it. So no harm, no foul, but we also didn't remove anything, right? If I change this to elephant, I'm going to test, does player 2 have an elephant key? If it does, then I'll go ahead and pop that elephant key. So now we see that it did actually remove elephant. Make sense? All right. So this is a question we could ask. We can say, look, I'm going to try to get the value associated with elephant. I know that get is friendly in that the program won't crash, but if it can't find it, it'll give me a nothing value, the value none. Okay? And let me just give you a little context here. None by other names. So in Python, it's called none. In other languages, it could be null. Well, it's usually a lowercase n, but we'll see if it lets me get away with it. Sometimes it's all caps null. Sometimes it's nil. Nil's another. These are all synonyms for like nothingness, emptiness. Okay? So none in Python is their equivalent of null or nil. All right, so if I try to get the value at a key and it gives me nothingness, then, well, if it doesn't give me nothingness, it says not equal to. If it doesn't give me nothingness, then I can safely pop that key because there's something there. But if not, then I can't safely pop it. I'll just move on with life because trying to pop from a non-existing key will cause the program to crash. And right now, we don't have a way around that. There's something called a try-catch that would allow us to force us to save face, but we don't know that yet. Go ahead.
Knowing this, you could probably write a better pop that doesn't.
Well, sure. Yeah, I mean, we effectively just did that. So, yeah, so he wants to do something like def pop, but the difference here would be it wouldn't be a function of dictionaries. It would be a function that operates on a dictionary. So we'd have to take in dictionary and a key, and then we can ask if the dictionary dot get that key is not equal to none. If that's a true statement, then what can I do? Well, then I can go ahead and I can say return dict dot pop. Else, I could choose to return none. Kind of make it act like the normal get. But now this pop, this version of pop, I wouldn't say player2.pop elephant. Instead, I would say pop player2 elephant. So my function I wrote up here is something that belongs to my program, not something that belongs to dictionaries. Make sense? All right. So questions about some of the normal functions of dictionaries? You can do all sorts of stuff with them, and you know, there's all sorts of crazy functions built into dictionaries that aren't listed here that I haven't necessarily worked with. Python seems to have a whole bunch of little shortcuts for things, and you can Google them real quick, and you've seen me look up a syntax real quick because, I mean, you know, Python is just like any other language, but if I haven't used some function in a year, it might not be fresh in my mind, but then once you see the syntax, you just use it. But I'm sure there's probably 50 creepy dictionary functions that do all sorts of stuff that you may once in a blue moon need to do. And you can either go and hunt for them or just write a function that does it, kind of like what we just did, and move on with life. Okay? So being a programmer isn't necessarily memorizing all the features of every language. Okay? If you're a construction worker, you know, you build houses or something like that, you don't have every single tool that Home Depot has. Maybe over time you get pretty close, but you don't have everyone. So whenever you're doing a job, you have an option. You can run to Home Depot and buy a tool if you think it'll make your life that much easier, if it's worth it in the budget for the project, or you just have your own little workaround, your way of accomplishing something with maybe 2 or 3 tools that you have that allows you to accomplish the same thing. Make some sense? Okay, so this is no different. We're effectively digital construction workers. All right, so let's pit some fighters against each other and see some death. Man, we got way too much excitement from that, I think. All right, so I'll leave our pop function up there. So we'll have a function here called fight to the death. And this guy will take in 2 players, player 1 and a player 2. And for right now, we'll just assume player 1 always gets to throw the first cheap shot. All right, so now our players have, actually what I'm going to do here is we're going to also write a function that creates a player for us. Rather than us having this kind of hard-coded in here, I'm going to write a function. Here, let me just for a second, just so that guy doesn't scream. I'm going to say, actually, I think, let me show you something here. I think it's called pass. Yeah. I think you can do this because Python will scream at you. If you try to run this, like I'm not ready to write the body of this yet. I'm testing something else. Python will scream at me right now and will say you have to write something underneath that function. So as a placeholder, you can throw pass in here. And that effectively gives you a function that won't crash your program. Okay? So this isn't necessarily something you would use as part of your logic, but gives us a placeholder just for syntax. All right, so I'm going to come back and write this in a few minutes. So for right now, I just don't want to forget about it. So I've written a little header for it, and I'm just going to let it sit for a second. But I want to go ahead and create a function that generates players. So we'll say get new player. All right, and this guy's job will be to spit a player out. All right, and so what do? We'll say, I'll just steal this logic right here. I'll make it a little generic by not calling it player 1. This is just a player. All right, so we'll say get new player. This guy creates an empty dictionary, fills that dictionary up, and ultimately we will return that player we just built. So now player 1 can be get new player. Player 2 can be get new player. Then we can print player 1 and print player 2. So there's our 2 unique players. Make sense? Okay. Now, keep in mind, all I did was take the same logic we wrote before, and I sucked it into a function, because already we were writing 2 players, correct? And both of those players were created in the identical way. So rather than writing the same code twice, I put it into a generic function that just says, look, when I call you, I want you to create a brand new empty husk, brand new empty player, fill it with the right randomy stuff, and then return that player to me. So whenever I need a player, like in this case, I'm creating player 1, I'll ask that function for a new player. Whenever I'm creating another player, in this case player 2, I'll ask that function for a new player. The same logic is happening that was happening before. We've just moved it into a generic function that I can call more than one time, rather than mimic that code multiple times through my program. This way, if at some later point in time, I decide that players are also going to have a player, I don't know, bonus or something like that. And this guy's rand int 1, 5. How we use that, who knows? But we just decided that our game now allows players to have bonuses. I only need to change it in that one function. I don't need to go find all the places where I created players, because these 2 players were both created in terms of that function, and I added that thing to that function. So now, from moving forward, all our players now have bonuses. Does that make sense? Okay, so that's get new player. Now, fight to the, so we have our 2 players here. We're going to call fight to the death for these 2 players. Now, when a player fights, he's going to probably decide if his attack power will be how hard he hits. For right now, we're not even going to use defense. We're just going to keep it simple initially. So if the first guy who gets to throw the first punch, if he whittles him down to 0 hit points sooner than the other guy, then he's cooked. It's just the way it is. All right. So we're gonna keep throwing punches. So let's throw 1 punch for each of them, right? So we'll go ahead and say P1, and we want P1 to reduce the hit points of P2. So we're gonna say P2 dot, or actually let's go this route. P2 at bucket hit points will get equal to whatever it currently is equal to minus P1 at bucket attack power. That's how hard the guy hits. So P1 attacks P2, P2's hit points reduce. Go ahead.
So for the future, when you're incorporating defense, you could just have defense will cancel out the hit points. So say if the defense is 5 and the hit points.
Yeah, we'd have to lower probably our defense then to have it. If we're gonna make this Dungeons and Dragons, you would probably roll a D20 or something like that, or a D10 to see if we clear their defense or something. But you're not wrong. We would probably just make this a smaller defense, where if somebody has a defense of 3 and they get hit for 5, they only take 2 damage, something like that. So I mean, that's all just how we want our game to work. In this case, we just want to see somebody die, is what it comes down to. Well, I said this is actually Christian worldview, right? I told you, was that in this class? From what's the Bible study? Yeah, 120,000 people, 60 of them they just turned on each other. The way it should be. You just sit there and just watch. That's what they did. This is the story of Gideon, right? Whew. Serious stuff. All right, so P1 smacks P2. P2's hit points go down. Then P2 is going to smack P1. P1's hit points will get set to whatever it currently is, minus P2's attack power. And then we want both guys to display themselves. All right, so let's just write a function here called display fighters P1, P2. And we won't do anything fancy yet. We'll just print P1 and we'll print P2. And we'll go ahead and say display fighters passing at P1 and P2. All right, so we create our two players. Then we call fight to the death on P1, P2. And why don't we go ahead and before we call fight to the death initially, we'll just display our fighters once just to see them before somebody throws punches. And then we should see some damaged folk following the two cheap shots. All right. Oh, these are called player 1, player 2. My variables here are called player 1, player 2. P1 and P2 are my variables inside my functions. All right, so here's our initial hit points, 25 and 31. And then this guy got hit for 2, making his hit points now 23. And this guy got hit for 3, making his points now 28. So on and so forth. Okay? So now we want to have them keep going back and forth until somebody dies. That makes sense? All right. So we need to, first of all, have a way of toggling between players. Okay. They need to be able to go back and forth in terms of whose turn it is. Any idea on how we can toggle back and forth? I mean, we're going to do something repeatedly, right? So when we do stuff repeatedly, what do we probably use? Some kind of loop, right? We're repeating something. So we're going to have a loop of some type. And we want to keep looping as long as what's true. Go ahead. Okay, well, really both of them, right? Otherwise, we have that situation of hitting the guy when he's down, which is funny. Right? Then you just put the infinite loop in there and just watch the bloodbath. So, as long as both dudes are alive, we want to keep cooking, right? How do we test to see if somebody's alive? What does it mean for P1 to be alive here? How do I ask the question? Is P1 alive? Go ahead. Okay, and how do I get P1's hit points?
What?
How do I get P1's hit points?
By doing while P1 at bucket hit points is greater than 0.
Yeah. So if that dude has hit points and this dude has hit points, both of them have hit points, let's attack. All right, so now we have to be able to go back and forth between who attacks. We're going to still assume that P1 gets to throw the first punch, so we get to kind of pick who's up. So each time through, the first time through this loop, P1 is going to hit P2. The second time through this loop, P2 is going to hit P1. The third time, P1 will hit P2, so on and so forth. What kind of logic can we put in here to make it toggle back and forth? Go ahead.
You could set like a counting variable and then the even numbers, P1 goes first and the odd numbers.
Okay. So you can do something like maybe turn starts off as 0, something like that. And you said that maybe when turn is even, it is P1 punching P2. And when turn is odd, it's P2 punching P1. Something like that. All right. So we'll say if. How do I ask if turn is even? Okay, so if turn mod 2 is equivalent to 0, that means it's an even number. And if that's the case, then P2 is going to get hit by P1. Else, P1 is going to get hit by P2. Now, regardless of who hits who, what do we need to do each time through? Go ahead.
Add 1 to turn.
Yep, so turn is equal to turn plus 1. So turn becomes 1 larger than it used to be, so that the next dude gets to attack. We could, forget about this, then it's just a pummeling. You want to watch those in slow-mo, though, right? Yeah. It's like so serious. Okay. How many of you do that where you're watching some movie and there's this is a really gory scene and you just keep rewinding it over and over again? Now what's funny is my wife hates when I do that because my wife, she doesn't like gore and things like that, but you know what her favorite show on TV is? No, I don't think she'd like that show. Walking Dead. Oh, you said that?
Yeah.
Can you? How could somebody who doesn't like any gore? She's like totally invested in this show. Yeah.
My mom has the same exact. My mom literally said the same thing.
Yeah, it's like my wife says she doesn't like the gore, but she likes the storyline.
Yes, that's exactly what she says.
Yeah. Now I see. I stopped caring about it once, they cut down on the violence. Yeah, it's too much drama now. Yeah. What was the best scene ever in that movie? Or in that show? There's only one correct answer to this question. And it's very much in line with what I've been talking about. Zombie Baby. Remember, was that season 2? When... Oh, yeah. That's so good. Just like the best scene of Breaking Bad. What was the best episode of Breaking Bad? There's also only one correct answer to that. No. You just title the show, it says it all. How many of you have seen all the shows of Breaking Bad? So you'll get this. Box cutter. Now all the normal people in the room are going to go watch box cutter. What a terrible teacher. Why would he say that? All right. But it is related to what we're writing in class, so it's completely legit. So, all right. So we have these guys going back and forth, back and forth, back and forth. And so first time through, turn is 0, so it's even. Player 1 will punch player 2. Else player 2 punches player 1. We'll increment turn each time through. And these guys are going to just keep going at it until somebody dies. Okay? And what we can do is at the end of each of these, we can go ahead and say display the fighters, P1, P2, so we can kind of watch the mayhem kind of unfold, right? And then when all is said and done, well, actually, we'll see the final state there. So as it stands right now, what does fight to the death do? Takes 2 players in, displays their undamaged state, starts our counter, goes through, and as long as both are still alive, it has one of them hit the other, and then it toggles back and forth. Eventually, one of them will die, and this loop will end. Okay? Start taking bets. Oh. All right, so player one has perished. He's at -4 hit points. He's had a rough go at things. Well, look how hard player two is hitting him. Just really cracking him. All right, so what we want to do for our homework, we want to, here, I'll put it, let me actually just write it in here. Homework. Add some randomness to our fight. First thing is randomize who attacks first. Somehow, however you want to accomplish that. All right? Keep in mind, whenever I say the word random, you're probably going to want to leverage rand int, right? Okay. Randomize who attacks first. Then randomize how hard someone hits. Perhaps a random number between 1 and attack power, something like that. Their attack power is 3. They hit for 1, 2, or 3. Something like that, rather than always hitting for 1. Build in effectively a dodge system. So perhaps an attack only lands if some random value is higher than the target's defense, something like that. Okay, so we add this idea of trying to hit an opponent. And then once we successfully hit an opponent, then we randomize how hard we hit them. That make sense? Last, add color commentary to the fight so that there is some verbiage based on misses as well as how hard hits are. So maybe it's something like player 1 swings and misses player 2 when there's a successful dodge. Or maybe it's something like if player 1 hits for his total attack power, you know, player 1 decimates player 2, something like that. Or if he hits for like a 1, player 1 grazes player 2, something along those lines. Make sense? Get creative with it. Doesn't have to be, you know, you can add randomness to it. I want you to practice using these dictionaries, and if you want to change some of your stats or something like that, or add some stats to make yours work, that's fine. Okay, so be creative, be funny, keep the profanity to a minimum. All right, questions, comments, concerns, bribes. I'll give you the current code as a starting point on Slack. All right, I will see everybody on Monday.